In this video, I want to talk about sequences and different types of sequences we can consider. So let's start with the definition of a sequence. A sequence is a list of entries occurring in a specified order. And these entries can consist of numbers, shapes, movements, colors, objects, lots of different things. And there are two kinds of sequences that I want to consider. The first is a repeating sequence. It's something that is going to repeat in order over and over. As an example, something like circle, triangle, circle, triangle, circle, triangle, etc. Another example, we could have something like R, Y, Y, R, Y, Y, R, Y, Y, etc. Another example would be a growing sequence. A growing sequence is something that is going to increase in some pattern. The most basic early growing sequence we have is the numbers, which do increase in a pattern. 1, 2, 3, 4, 5, 6, etc. If we want to make it a little more complicated, we could do the squares. 1, 4, 9, 16, 25, 36, etc. Or maybe we want to look at even numbers, 2, 4, 6, 8, 10, 12, etc. And these growing sequences are the ones I want to talk a little bit more about. One of the basic types of growing sequences is an arithmetic sequence. An arithmetic sequence has a starting point chosen, and we repeatedly add a number to get the next entry. As an example, if I want to start with the number 3 and repeatedly add the number 4, 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19, etc. And the main thing that defines this arithmetic sequence is that it is the same number that is repeatedly added. And with these sequences, we can actually find a formula to actually get the nth entry if we want to get the 50th entry or the 2000th entry. So we know that we're repeatedly adding 4. So that starts us with this 4 times n. But we started at the value of 3. So if n is equal to 1, the first entry, I should output a 3 here. But currently I don't. I output a 4. So I need to subtract 1. Then my first entry is 4 times 1, which is 4, minus 1 is 3. The second one, 4 times 2 is 8, minus 1 is 7. The third entry, 4 times 3 is 12, minus 1 is 11, etc. Next, I want to look at geometric sequences. While arithmetic sequences repeatedly added the same number, geometric sequences will repeatedly multiply the same number. So we pick our starting point and we multiply by a given number over and over and over. As an example, I picked a starting point of 2, and I repeatedly multiply by the same number to get the next entry. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. So I'm repeatedly multiplying the previous entry by 3. And just like before, I can get a formula to give me the nth entry, where n is the number entry I want to get the 5th entry or the 2000th entry. Since we're repeatedly multiplying by 3, and repeated multiplication is denoted by an exponent, then we'll have a 3 to the nth power. But once again, that doesn't quite work. 3 to the first power is 3, and I need it to be equal to 2. So I'm going to multiply that by 2 over 3, because then 3 to the first power is 3, and 3 times 2 over 3 is 2. For the second entry, 3 squared is 9, and 9 times 2/3 is 6. And we can continue this process to see that this works and will give us the general formula for this geometric sequence.